What's up? What's up? What's up? It's your boy, the network. Hashtag lab every day, because this is what we do. We lab every day. Today's topic is subsection 3.1 D Delta DHCP protocol operations. This is a subsection of section 3.1, identify, configure, and verify IP addressing and subnetting. This is a topic in the CCNP route exam code 300-101 version 2.0. Let's look at the exam blueprint, see where we came from and where we are headed. Again, this is implementing Cisco IP routing, CCNP route exam code 300-101. Let's see where we came from. We just wrapped up DHCP relay and server, section 3.1C. This was just a basic, basic configuration that we did, and, basic summary of both of the topics, relay and server. Right now, we're just going to go just a little bit more deeper in section 3.1D, DHCP protocol operations. We're going to break down each of the steps that we talked about in the last video, which was the Dora, if y'all remember that. And after that, we're going to move on to IPv6. That kind of scares me. It gets kind of tricky, but IPv6 it's a little simpler, but it's just the long numbers kind of scares me at least. And we're going to move on to Unicast. For now, we're doing protocol operations. Again, DHCP stands for Dynamic Host Configuration Protocol, and that is a service that is usually on a server or router or layer 3 switch that hands out IP addresses to clients on the network. Clients on the network needs IP addresses to communicate, and that's what the DHCP server does. A server, again, could be a router or an actual server. It could be a VM server, whatever. So as far as the protocol operations, the easiest way to remember, I told y'all this in the last video, is Dora, kind of like Dora the Explorer. Y'all remember this cartoon, right? The little girl that speaks English and Spanish, right? So Dora stands for, the letters Dora is an acronym that stands for discover, because it sends a discover message. O for offer, R for request, and A for acknowledgement. And we're going to break down each of one of those steps. Now that's Dora right there that y'all might remember, but this is the Dora that I like to acknowledge, the one on the right here. This is her before taxes on the left. Shout out to teamdominican.net. And this is her on the right after she ain't go to Dr. Miami. She know it's cheaper to go to Dominican Republic and, get her butt done and get her stomach right, So this is the Dora re-acknowledge, all right? So let's break down. First of all, let's break down the header. Every time a message is sent to and from a client and a host, this is the header that's tacked on to the frame, right? On the left, we have the opcode or operation code. So the operation code specifies the DHCP message. It's either going to be a 1 or a 2, right? The 1 is sent by the client, right? So when the opcode is set to 1, this guy right here, when that's set to 1, it came from the client making a request. If it's a 2, it's sent by the server. So that's a reply from the server. So remember, 1 for the opcode is request, 2 is a reply. The hardware type specifies the local area network architecture. That's usually it's usually Ethernet, I believe, and that's usually set to 1. The address length is usually is value 6. That's also Ethernet. The hop count is how many hops it took before it gets to a DHCP server. So remember we talked about what a relay is, right? The relay is the third party that takes requests from the client and send them to the server. You might have to go through 2 relays before you get to the server. This hop count tells you how many hops it took before you got to that server. The number of seconds is the elapsed time since the client began the DHCP process, right? We also got the flags, which is unused in bootp. Bootp is kind of like the, I believe, DHCP is the predecessor to bootp. So we used to use bootp back in the day, and now we use DHCP basically. So those are the flags right there. It's called the broadcast bit. It can be set to 1 to indicate that messages to the client must be broadcast. So that's what this flags field is for. The transaction ID that's used by clients to match responses from the server with previously transmitted requests. The client IP address, that's self-explanatory. Sometimes you see these, they'll be like CIDDR, and then this is your IP address, which is obviously is the client's address that was set by the server. So that's, I think it's like CIADDR. I'll probably put them in the notes below. We may have a lot of notes for this because there's so many, as you see over here in the gray at the bottom. We're gonna go back to all these. These are all self-explanatory. Your IP address, the server's IP address, the gateway's IP address, the client's hardware address. Remember, hardware is also known as the burned-in address or the MAC address. So this is going to be the client's hardware address. Oh, by the way, this header is 32. I believe it's 32 bytes. Yeah, I believe it's 32 bytes. Anyway, that's the MAC address right here. I don't know how it's 32 bytes if these other bytes are tacked on. I mean, this other information is 16, 64. That exceeds 32 bytes. So leave it, y'all. I'll probably research that and put that in the notes below. If you know the answer to that, go ahead and leave a comment below. But the header is 32 bytes, but yet these look like they exceed 32 bytes. Please leave a comment below. Let me know. That's the server's host name. Boot file name, that is the name of the file for the client to request from the next server. For example, the name of the file that contains the operating system for this client. That's what the boot file name is. And then the options, I'm not going to really get into that. I'm going to leave a link in the description. That's actually a book. It's about 100 some options. That number right there and the size of it, of this options field, is variable. It could be any size, but it's a whole bunch of options. The one you probably really need to remember is option 82. That is for the DHCP relay agent. Again, there's so many options. I'm not going to discuss all of them. There's just so many options. All right, so moving right along. First thing, this is the D option. I mean, the D process for the Dora process. D, right? Discover. The first thing he does, the DHCP client broadcasts a DHCP discover message on the network. I'll show y'all this in Packet Tracer if y'all really want me to. I'll break it down for y'all. Actually, we'll do it right now. So the broadcast the DHCP discover message on the network subnet using the destination address 255.255.255.255. The specific subnet, you'd have to know the broadcast address for that network. And then he'll send it to 255, but the one that'll respond to it is the broadcast address. Or actually, that's the one he'll send it to. I'll probably leave those in the notes below of some examples of broadcast addresses. The DHCP client may also request its last known IP address because sometimes you could renew a lease. Let's say his, on the left-hand side, let's say his IP address used to be 192.168.1.5, right? He had it last time, and then he rebooted or he went to sleep. He came back on. He'll request it again. That was his last known IP. So he'll just renew the lease. Over here on the left, as you can see, the client uses the UDP. They both use for discover DHCP messages. The client and the server communicates through UDP ports. Client goes through 68. Server responds on 67. The client really wants the IP address, so that's why he got a higher number. I'm just kidding, but that's how I remember it. The higher number, 68, is higher than 67. So he remembers it. He wants it more. These are the little things I do to remember these, like port numbers and stuff like that. Actually, before we move on to offer, let's just send a discover message real quick. This is a Packet Tracer. Yeah, I know I love Packet Tracer. I'll move on to the DNS3s pretty soon. Don't worry about it. All right, so let's go to simulation mode and have PC1. As you can see, we've got 2 local area networks, right? Actually, we got 3. We got the 10.0 network, the 30.0 network right here. So 10 network, 30 network. We got the 20 network, which contains the DNS server. Then we got the internet right here, cisco.com and public site, right? Let's have PC1 from the 10 network send a discover message, because right now, as you can see, command prompt IP config, he got no IP address, 0.0, right? So let's go ahead and request an IP address. IP config / renew. Boom, right? So now we've queued a DHCP discover packet. That's what this is. Let's open him up. This little olive envelope or yellow envelope, whatever you want to call it. Outbound PDU. This is the Ethernet frame. This guy right here, as you can see, Ethernet. This is the IP header we talked about before. 32 bytes, right? Source, he don't have an IP address yet. Destination, broadcast. This is the UDP message, port 68. He's sending it through port 68, right? Destination, port 67. So send it to the DHCP server. And this is the DHCP header that we just mentioned before. This guy right here. So that was the UDP header right here, right? Let's go over again. Ethernet frame, IP header. Go ahead and pause it if you need to. UDP header. Go ahead and pause it if you need to. DHCP header. Go ahead and pause this. I'll make this a little bigger for y'all. Oh, and that's the options field right here. Go ahead and pause it right here. All right, moving right along. Client address is 0, right? Second 0. Hops 0. We haven't taken any hops yet, but when it comes back, it'll tell you how many hops it took, right? We got, let's see, we got none of this information because we don't know it yet. We requesting it. Client's hardware address. This is my MAC address, right? All right, so that's a discover message. Okay, so now the offer message. I can't really show y'all that right now because we have to set up DHCP and probably the relay service and all of that. We gonna configure all of that all together so I can show y'all how all of that works. Again, he sends offer to the client. So this guy right here, this is the server. This is the router in this case. He gonna send him an offer. He gonna give him an IP address. Like, hey, here go your IP address, your subnet mask, default gateway, etc. Again, he responded on port 68. So that's the offer. He's gonna offer the information, and then the R stands for obviously request. He requests. Okay, he likes what he sees. He likes the IP address. He likes the subnet mask and all this other information, and he sends it back to the server. The server's like, okay, you like this information? That's the request. The request is also a broadcast because he don't really know the IP address of the server yet. He does actually, but he sends a broadcast. I don't know why. If you know the answer to that, go ahead and put it in a link. Just go ahead and put it in a comment. Put it in the comment section below. But he still sends a broadcast as far as the request goes. He don't send no unicast yet because you would think because he knows the client's the server's IP address now, he should just start sending unicasts. But he don't have an IP address yet, so maybe that's why. And then finally, the DHCP server remembers the MAC address of that client, and he remembers the IP address that he offered him, puts it in his DHCP, also known as binding table or DHCP database, however you want to call it, and then he sends an acknowledgement. He says, okay, you like this information? Okay, signs off on it and sends him that information, and then the client starts using that address. And when he sends him that information, this is wrong right here. Remember, he actually sends it through port 67. We're going to double check that in Wikipedia, my favorite source, which is also editable, I remember. But the server uses 67, client uses 68. I'm going to double check. If I'm wrong, I'm going to come back on the links. I'm going to come back and put it in the description below. Again, he puts that in his DHCP table. The way we can view that is show IP DHCP binding. We can see the DHCP leases that were given out. He could also renew the lease, as I mentioned before, if he goes to sleep or he reboots or his lease, the lease ran out. By default, I believe it's 24 hours for DHCP IP address lease. And after that, it gets expired, and he could renew. He could ask for the same IP address. So if you don't have a shortage of addresses, what happens if you run out of IP addresses? I haven't been in that situation before. Research that and put it in links below. I'll probably have a lot of information on this video right here. Remember, these notes are for me, but this whole journey, this whole thing is my CCNP journey. I'm just sharing it with the world. Again, this is the Dora process as a whole. Again, the discover message gets sent through 68. Remember, client 68, server responds on 67, 68, 67. So destination, see, destination is 68. So I guess he talks on 68, right? He uses port 68. When he sends him a message, he'll respond on 68, but he uses 67 port. And just take a look. You can pause right here and take a look at it. So discover, offer, request, acknowledge. Just remember Dora Explorer. That's the easiest way to remember it. So let's move on to Packet Tracer and kind of go a little bit further in depth. I showed you the discover header. We may break it down as far as the offer. Once we get it all complete, we'll do a discover offer request and look at the header again. And let's go ahead and set up a couple pools. We're going to set up a couple pools for this local area network. We're going to set up some pools for this local area network. We're going to use this DNS server to communicate with these servers right here. First, let's bring up the instructions. Again, this came from the Cisco Academy. Step 1, configure a router as a DHCP server. Remember, a server could be a Windows server. It could be a Linux server. It could be a router. It could be a layer 3 switch. Whatever. It's a DHCP is a service. It's a protocol. So it's not necessarily always a server. We're going to configure router 2 to exclude the first 10 addresses in the router 1 and router 3 local area networks. Why would we want to do that? Again, we could have some addresses that we want reserved. We don't want to hand those addresses out. We could use them for testing purposes. We use them for static IP addresses, so that way they're not handed out. If we hand them out and we wanted them to be used for other purposes, we could have a conflict on our network. We have duplicate addresses. We don't want that. Let's go ahead and just go to router 2, CLI, and enable configure terminal interface. No, I'm sorry, IP DHCP excluded addresses. The addresses we're going to include are first 10 from the router 1 and router 3 networks. Router 1 network is 10.0, right? First 10 addresses. Go ahead and pause and think about that. Move right along. IP DHCP excluded addresses 192.168.10.0 and 192.168.10.10. Wrong 2. I'm sorry. My bad. This is supposed to be 10.1. Not the 1, not the 0, because remember the 0 is a 0 network. We don't hand out the network address. So that's for that address. Let's go ahead and remove that first one because I made a mistake there. And this is why we lab every day, because no, right? So IP and then the router 3 local area network. What's router 3 local area network? 30.0 network. Right? IP, DHCP, excluded addresses. The low address is 192.168.10. I'm sorry, 30.1. High address 192.168.10. Sorry, see how that's by force of habit right there. 30.10. Okay, move right along. Create a DHCP pool for the router 1 LAN. All right, so IP DHCP pool, and then we will create the name, which is R1-LAN. It's case sensitive. And then we're going to configure the pool to include a network address, default gateway, and the IP address of the DNS server. What's the DNS server's IP address? We got it here in our addressing table. First, let's start off with the network address. What's the network address for router 1? Network 192.168 is what we tried to add before. .10.0. Oh, we got to do the subnet mask. My bad. 255.255.255.0. See, this is why we lab every day. Little things like that. The default gateway is going to be, we're going to make router 1 there, the 10.0's network's default gateway. What's router 1's IP address? Is it the serial or is it the gigabit? Should be the gigabit. Let's do that. Default. What's the command for that? Default router. You would think it should be default gateway and then the IP address, right? 192.168.10.1. That's the default gateway. Next thing we want to do is the IP address of the DNS server. What's the DNS server's IP address? Let's go into DNS server and do it. Desktop, command prompt. I'm just being a little fancy, y'all. Configure IP config. So that's the IP address of the DNS server. Copy that guy. Close. Go back to router 1 and make that. No, I'm sorry, router 2. Make that the default gateway for this local area network. Right? I'm sorry, not the default gateway, the DNS server. So it's DNS-server, paste, and that's the DNS server for this local area network. And that's it for the router 1 local area network. Now we got to create. Let's see what we got so far. Remember last time I did show runs, but the way to challenge yourself is not using the show run. Let's do the commands that's used for DHCP services. Show commands for it. Show IP DHCP. Let's see what we got. We got binding, conflict, pool, and relay. What did we configure so far? A pool. Let's do pool. That's the pool right here. We got the name of the pool, the utilization mark, how many we've given out and how many we have, we've got so far, the subnet size, total addresses, least addresses, none. We're excluding 2 addresses. I don't know why I say 2. It should be more than 2 because it says first 10 addresses. I don't know. We may have to research that. Yeah, 10. Yeah. Anyways, this is the pending event, none. So we've got least, excluded 2, total 254. It's something wrong here because we should have excluded 10 addresses there. So we'll look at that in a second. Let's double check actually right now. 10.0. No, 10.1 through 10. Right? Yeah, 1 through 10. So you would think, I don't know. We'll look at that. All right, so let's go ahead and create the router 3 local area network. Right? So we did router 1's local area network, but now we're gonna do router 3. All right, so let's configure terminal. Oh, sorry, we was there. IP. Y'all remember the command to create a pool? Pause right here and think about it. All right, we back. IP DHCP pool. Then the name of the pool R3-LAN. Remember, this is case sensitive, so I did a lowercase right there. We got to put it in caps. Local area network, right? And then we're going to configure the network address. You remember the command for that? Pause right here. Think about it. We back. Network. The name of the network, the network address of this network, which is what network is this? 30.0 network. Right? So network 192.168.30.0. What we forgot last time, the subnet mask. This time we're putting it in 255.255.255.255. I'm sorry, .0. Pop quiz, what's the subnet mask? Insider notation. /24. It's up here. There go your answer right there. I just do this stuff to kind of like, help y'all, think about things real quick on the fly. These things kind of help you out. At least they help me out. Remember, these videos was for me. I'm just glad y'all watching. The default gateway, router 3's, the local area network default gateway is going to be his this interface right here, basically. So let's look at what that is. The local area network's interface right there, 30.1, right? So what's the command to set the default gateway in DHCP? Pause right here and think about it. All right, we back. It's default router, not default gateway. You would think it's default gateway, but it's default router. 192.168.30.1. Right, now we're gonna do the we did the DNS server. DNS server is right here, right? 192.168.20.254. All right, we halfway done, y'all. That's the DNS server's IP address. So we created 2 pools. Let's double check that again. Actually, let's do a copy run start to save our work. Do show IP DHCP binding. My bad. Binding. No, we ain't bind no IP addresses yet. That's why it's blank. Nobody. We haven't given anything out yet. So we haven't gotten any. We haven't done that yet. Let's go ahead and do show IP DHCP. See, I got to think about this one. It's not relay because we haven't done the relay yet. I give up. Pool. It's pool. P-O-O-L. I could have just went back and did a question mark to double check. But see, now we've got 2 pools, right? We got the router 1 pool right here. Go ahead and pause and look at it. And then we got the router 3 pool. Pause and look at that. All right, we back. Let's go ahead and we've created our pools. Let's configure the DHCP relay agent. Why do we need to do that? Take a look at this topology and think about that. Why do we need to configure a DHCP relay agent? All right, we back. Router 2 is our DHCP server, right? But notice the pools are for this network and that network. But their default gateways are these guys, right? So we need to set these guys as DHCP relay agents. Router 1 needs to be a DHCP relay agent, and he needs to be a relay agent. So that way, when he sends a DHCP request and he sends a DHCP request, they're going to go to that router, their default gateway, and then he's going to relay that request to router 2. Router 2 is going to give him his DHCP configuration information. Let's go ahead and set these guys up, 1 and 3, as relay agents. Y'all remember how to do that? Pause and think about that. All right, we back. So exit, actually enable, configure, terminal. We know the requests are going to be coming from this interface, right? The requests are going to be coming from the .O network. Without looking at the address table, this is how we're going to figure it out. Do show IP interface brief. We know we got 2 interfaces here, right? One that goes to our 10 network, and one we gonna be sending our relays to. So where we gonna look at this topology and take a look at where we're gonna be coming from, where the requests are gonna be coming from. We back. The requests are gonna be coming from this one. So let's go to that interface. So interface GI00 IP helper address, and we put the IP address of the DHCP server. Which address do we put? We put that interface, which is the serial 000 interface. I'm just gonna go to the addressing table for that. So router 2 serial 000 interface is 10.1.1.2, right? So 10.1.1.2. And that's the helper address, right? So again, we go to the interface that the requests are going to be coming from, the closest one, right? And then we put IP helper address and then the address of the DHCP server. Y'all got that? Let's go to router 3 and do the same thing. Enable, configure, terminal, IP. No, we got to go to the interface first. Interface. Let's look at our commands again, or our interfaces. Do show IP interface brief. I could actually just do this real quick without trying to explain, but I go back and look at these videos so I remember how to do this stuff. Serial 00001, right? No, my bad. The Gigabit interface, the 30.1 network, 30.0 network. So interface GI00. That's where the discover messages are going to be coming from on the local area network. IP helper address. What address is going to be we put here? Pause here and think about it. We back. It's the DHCP server's address. But the interface, which interface do we put it? Looking at this, we put this interface right here. How we know what it is? It's the only one that's connected. So it's in the 10.2.2 network, right? Looking at this address guide, you can see it's 10.2.2. That's this serial interface's IP address. So 10.2.2.2. I don't think you got to put Subway. I'm hungry. It's 5 in the morning. I'm thinking about Subway. That's the helper address. The address of the DHCP server. Move right along. We configured our router as a DHCP relay agent. Now let's set PC 1 and 2 to receive IP addressing information. Let's start with PC 2. Right now, you don't have an IP address, do we? Nope. Config. Let's just do IP config. You can see he don't have nothing. All zeros, right? You think by now he should have got an APIPA address, right? Remember what APIPA is? A 169 address. IP config / renew. We in simulation mode. Let's go ahead and do that. Let's go ahead and take a look. Let's look at the header. Right now, we sent, this is the DHCP header, right? Opcode 1. This is a request. It's the last number there. 1 is a request. 2 is a reply, remember? No hops yet. We don't have an IP address yet for the client. My address is the client. You would think the client and your client is the same thing, but I think this is the, no, that's the server address. Relay agent address. Client hardware address. That's my MAC address. Server host name, we don't know it yet. File, we got a million options that we could put right here. Right now it's 312 bytes. Fast forward. Right? You see that right there? See where it's going? I'm going to router 3. It's going to router 2 now. He relayed it this time. He relayed it. And it's coming right back. Let's see what we got so far. It's coming right back. He gave me some information here. Router 2, outbound PDU, right? Let's look at the DHCP options. 2, this is a reply, remember? Now it's a reply. No hop so far. Hardware type, those are usually static. Client address, 30.11. Relay agent address. Should be this guy. Should be his IP address, but I don't know why it's 0 right now. I think he'll get it though. Let's fast forward again. And he arrived. Right? Let's take a look at him. Inbound PDU. Let's look at the DHCP header, right? This is the DHCP header. Now, my client address. No, your client address. 30.11. See? Now we got an IP address. We can verify that. This is a reply. See? It said 0 hops because I don't know. I thought it should be 1 hop there. I'll double check that and let y'all know. But anyways, let's go back into real time. Let's look at his configuration information. And now we did a renew and we got an IP address, subnet mask, default gateway, and a DNS server. Let's do the same thing for PC 1. Oh, we already got it. We already got it. Let's renew. IP config / renew. We got another one. This is the same address actually, right? Let's go ahead and go to router 2 and view our bindings. Exit. I could have just Control Z. Y'all know that shortcut. Show IP DHCP bindings. This is what we've binded so far. We haven't set a lease yet, so these are blank. So we've got their IP address. We gave them an IP address, 4885.1470. See? Y'all see that? All right, so now let's move on, and so that way we can go to sleep because I'm tired. We got to bring up this interface right here so that way we can communicate with on the internet. We got 2 servers we can try to get to, cisco.com, publicsite.com. The way we do that is, first of all, we can set this interface right here to receive an IP address. Let's do show IP interface brief. It's the serial 010 network, right? Serial 10. No, that's not a serial interface. It's actually the Gigabit 01 IP address. So, have we done that yet? Yeah, Gigabit 01 interface. That's what we skip right here. Configure Gigabit 01 on router 2 to receive an IP address from DHCP to inactivate the link. Now, this is one of the few things I kind of didn't know, I guess I would say, that you could set up DHCP for an interface like that, but that is a way you do it. So configure terminal interface GI 0/1, right? Instead of statically putting an IP address, so you're going to do IP address, and then notice you can put either the IP address statically putting it in or DHCP. We're going to do DHCP. Now he just received an IP address, but he received it from the ISP. No, actually, he received an IP address from DHCP from itself, I believe. Yeah, I believe it's from himself. So now we're going to do a no shut. Now that it's up, we wouldn't have been able to communicate with it through the network. So now we'll be able to communicate to cisco.com and publicsite.com. Let's go ahead and do it. Bring him up. Command prompt. Oh, I'm so glad I left the headphones out. There's something wrong with my speakers, and I haven't really took them out yet. I'm sorry for the bland personality today, but it's like 5 in the morning. I need to take my behind to bed. We're going to ping Cisco. And actually, it's publicsite.com. Now, remember, he's going to get the translation information from the DNS server to be able to communicate out the internet. Ping publicsite.com. Waiting for a reply. Are we in simulation mode? No, we in real time. May take a minute. It says unreachable right now. Let's try it again. The host is unreachable. We did set a it timed out. There we go. There we go. Reply. 50% loss. Sometimes it takes a little bit to get the information. You may have to ping it a couple times. You'll notice that in this field. Sometimes you got to ping it a couple times before you get a reply. Publicsite.com. Let's go ahead and get out of that and ping Cisco.com, which is the other guy on the internet. Timed out. Got a reply. We good to go. If you like this video, please comment, like, subscribe to the network.